Hello everyone and welcome to my YouTube channel. This is episode 2 of Threat Detection Lab series. Today we'll be setting up the Windows box and the Ubuntu box, and we will so that we have all the three virtual machines up and running before we start integrating them and configuring them. So we'll quickly get started. So we'll quickly start by grabbing the ISO for Windows and ISO for Ubuntu. I'll paste this link in the description, and this is the link that you need for getting to this page where you can download the ISO. So what we'll be doing is downloading the 64-bit edition of the Windows 11 Enterprise installer. So click on this and you'll get a download prompt for around 5.78 GB. I'll skip this because I have already downloaded this. And what you also need is to download the latest Ubuntu ISO. We'll download Ubuntu desktop. It comes with a GUI, so easy to configure. And we also will be going with 24.04 LTS. So you can click on this. It's a 6 GB download again. It will start automatically downloading. You don't need to do anything. I will also skip this because I have already downloaded both of these ISOs and I have them ready. But you can go ahead and download them. I'll paste both of these links in the description for your reference. So now that we have the ISOs, we'll quickly continue and start setting up the virtual machines. We will quickly open our VMware and I'll just create a new virtual machine. Let's say typical, select Windows 11 ISO. The thing with Windows 11 ISO is that it should be detected as Windows 11 x64 as a prompt here. You should be seeing this prompt, because if it doesn't, you will not have the next few screens that says encryption. There is a trusted platform module that is introduced in Windows 11, and VMware Workstation Pro 17 only has the capability to add that module. So if you are using Workstation Pro 16, I would highly recommend you do not download Windows 11 and download in Windows 10 ISO, because 11 requires you to have that virtualized trusted TPM module, right? So you would need Workstation 17 Pro for Windows 11. We'll just name this as Windows 11. We'll click next. Yeah, this is the screen that I'm talking about, right? The encryption information. This screen will not be visible if the ISO is not detected correctly, or if you have Workstation Pro 16. So what we'll do is only files needed. Yes, we'll just put a random password. Click on next. I'll be putting on around 300 GB of space. Feel free to customize it, but I would highly recommend that you move it above 150 GB at least, because you'll be installing a lot of tools and softwares on that VM. It shouldn't be that later you realize that the space is low, but you can always go ahead and add a second disk to this virtual machine later. We'll put it on bridged until the installation finishes. We'll leave all of these settings as it is. I'll say close, power on, finish. Okay. We press enter. The installation process start. So if you right click on this and go to settings, you see there is a trusted platform module is added. So this module is essential for getting Windows 11 up and running, and it is the minimum basic requirement of Windows 11. We'll click on next, we'll click on install. Okay, let's accept. We'll do custom. The 300 GB unallocated space is there, so we'll click next. It will start copying files and installing. I'll pause the video here and let it install. Meanwhile, this is loading up. Let's try to set up a second virtual machine for Ubuntu. We'll click on new virtual machine, typical, next. Select Ubuntu. I have Ubuntu 23.10. You might have Ubuntu 24.04 LTS version. Doesn't matter. For the sake of this lab, we just need a Linux base OS. So we'll click on next. We'll say personalize it. Ubuntu machine. We'll put 200 GB of space as it will be storing logs. Click on next. And we'll customize and remove it to Brest for installation. Say finish. Let VMware create this virtual machine. We'll go back to our Windows installation and see if things are going smooth here. Okay, this is getting ready. Let's fire up our Ubuntu machine for installation. Meanwhile, we'll just keep on checking in this virtual machine to see if everything's going smooth. Okay, I think Windows machine has restarted itself. It is progressing as expected. Ubuntu is still loading. You could choose to install them sequentially, one after the other. For the sake of this video, I have tried to install them both parallelly. Yes, is this country or region right? Let's select the country where I am based out of. India, yes. Keyboard layout, India yes, skip. Meanwhile, we can go and start doing the same thing. Select your language, English, install English US. Okay, just test. Okay, next. Use the wired connection. Since it's a virtual machine, your bridge network will be detected as a wired connection. As you see, the internet is already available, so it's not detected as Wi-Fi but as bridged. Sorry, wired. Click on next. The current okay does. Let's skip this. I think you wouldn't get that screen if you are doing an LTS version. Default installation, third party for graphics and Wi-Fi hardware. That should be enough. Erase disk install and install. Next. Click on next. Dark. We'll let it install. We'll go back to Windows. Okay. Okay, let's try to do domain join and put this next to the password. Create a super memorable password. Confirm the password. And next. Okay. And for the sake of video, I'll just enter ABC. City you were born, ABC, D. First school, A, B, C, D, E. Next. Accept. Okay, we'll let this work. Go back to Ubuntu and check how things are rolling in. Okay, still installing the system. One thing that I would like to mention at this point is, if possible, try to get the Ubuntu 24.04 LTS version, or for the sake of setting up your labs, get the LTS version. They are stable. I'm running at 23.10. I feel it's a development versions. You see there are glitches in the UI and things like that. I'll probably swap this out for 24.04 later. But if you're trying to set up a new VM, highly recommend go with 24.04 or LTS. Okay, this is setting up. Okay, so our Windows machine is finally set up and has logged in. Okay, I finished installing. Refresh. Can go to, as you can see, there is a banner at the bottom, right? Windows 11 Enterprise Evaluation license only for 90 days. Okay, which is expected. We have 300 GB of disk. Let us check the properties. Okay, looks good. So what we'll do is we'll now try to take a backup of this VM, right? So we'll take a snapshot, base Windows installation, clean Windows setup, take snapshot and let it save the disk, save the image to the disk. Meanwhile, Ubuntu is still rolling in. Let us see if we can change the resolution. Last time I changed the resolution, some weird things started happening. So I'll see if I can just put it to skip changes. Now one thing that you can do here is basically install VMware tools. That would improve the performance a lot, right? You would start getting better display quality, better visualizations, better performance, drag and drop facilities. But for the sake of threat detection engineering, I would not recommend you to install VMware tools, because there would be malwares that you would be working on or researching or detonating that would look at that process or a binary running in your Windows environment and detect that it is a VM and would not behave as it is expected to behave, right? So try not to install the VMware tools, but if you're facing a huge performance drops or anything, feel free to go ahead and install it. But do it after taking a backup or a snapshot, so that you can always revert to that snapshot later, say if you want to do or research a malware that is VM aware, right? So our Windows VM is set up. We'll just say, okay, our Ubuntu has also set up. We'll just restart now. Awesome. So our Linux has also logged in. We'll click on skip. No, do not send our info. Location services not required. Done. Right. So this is Ubuntu, and if you go to terminal and if you do sudo apt-get install open VM tools, it would say that set to manually installed, right? So VMware has already taken care of installing VMware tools on Ubuntu, and it is fine to install these tools for performance improvement here, because we'll not be detonating malwares on this logging server, right? So this is fine. We'll just take a snapshot here as well. Clean Ubuntu, clean machines snapshot. Let's take a snapshot. We'll say don't upgrade. Yeah, it is asking us to upgrade to 24.0 for LTS, right? We can do this later. Okay. So at the bottom you can see saving state 24%. Let it complete. Meanwhile, we'll just shut down our Windows. Okay, and we'll rename this as Windows 11 victim box TDR threat detection research for reference, and move it to our desired folder. We'll do the same with Ubuntu once the snapshot is ready. But as you can realize from the architecture diagram, Windows box is sitting on the LAN side of things. So we need to move that box to LAN so that we have control over that box via a firewall, right? So what we'll try to do is now change the network interface on the Windows box. So we'll go to network adapter, custom. Okay, we'll select VMnet2. VMnet2 is, I believe, where our firewall sits. So let's just see the firewall config as well. Firewall sits on VMnet2, right? So we'll turn on the firewall first. Still at 40%. Let this firewall load. Okay, so the firewall has loaded. The IPs are correctly assigned as per the configuration we did last time. So now the firewall is loaded, we can start our Windows machine so that it automatically gets an IP address via this firewall device interface. You can also go ahead and take a snapshot of firewall if you're interested, while I have not taken that. You generally don't need to change config of firewall or reverse the state of the firewall again and again. It's an appliance, right? The environment would be required to be reversed, and that is when you take the snapshots of, say, Windows or Linux boxes. Okay. We have logged in, and you see there is no internet connection. It says network 2, no internet access. Okay. Use Edge. Start without your data. Confirm and continue. Continue without this data. Confirm and start browsing. Okay. What we can do is, let us first go to terminal and check it's partial. Let's do command prompt and do ipconfig to check if we have an IP from the VMnet2 subnet. So our subnet range was 192.168.10.0, right? So as you can see, we have got an IP 192.168.10.10, which adheres to the range that we defined it for. We'll try to see if internet is accessible. Okay, we have internet from LAN to WAN, and you see at the bottom the icon changed, so it says now we have internet access. So our firewall is basically routing traffic for all of this, right? So we should be having control over this box via firewall. And how do we check the firewall? We check it via from any LAN device that you have and that is connected to the firewall. Let's go to 192.168.10.1. as that is the firewall IP. But if you can go back in your terminal, you will also see the default gateway is also that same IP. So the traffic is routed via that IP, right? So we'll do root, we'll do the password that we changed and to now. So this is our firewall interface. You have all the information, reporting, health, everything available here. And if you go to firewall rules, LAN, you can see there are rules available here, and this is the area where you will start creating more rules if you want to have a control over your virtual machine, that is Windows, right? So now we'll go back to Ubuntu. We'll log in. Yep, it is all working fine. So now we have 3 virtual machines. If you refer to the architecture diagram, we have 3 virtual machines, and we have control over this virtual machine over via firewall. So this setup looks fine, but let us put some guardrails around it. What I mean by guardrails is currently the setup allows this virtual machine, the Windows box, to connect to any other machine in the LAN as well as WAN, right? So we should be limiting it just to so that it is not able to connect to the host machine. For example, the host machine that I have here has an IP of, let us check the IP, has an IP of 192.168.0.239. So if I go to my Windows box and if I open terminal and let us try to ping 192.168.0.239, this will pass, right? That means this machine can connect to all the devices that are present on my home Wi-Fi network. That includes my mobile phones, other Windows devices, or other laptops that I might have. So there is a risk that the malware that I detonate here can actually move out of this or laterally move to other devices, right? So we should put some guardrail that would contain network connections connect from this virtual machine, right? So we'll go to the firewall interface. Go to firewall, we'll go to rules, we'll go to LAN. Now you see there are automatically generated rules here. 19 rules were automatically generated, and then there are few default rules that are created. What we'll do is we'll create a new rule that says block on the interface. Protocol is any, so it will block connections that follow any protocol. Source should be from this LAN network. Destination should be to the WAN network. We'll write description. Block all connections from LAN to WAN. And click on save. And we'll click on apply changes. Now this creates a rule, right? Let us try again. It's still happening. Why? Because there is a precedence of our rule order. So what happens is the top level rule has the highest priority. So what we need to do is select this rule and move selected rule before this button. We click on this. So our rule comes at the top. Now we click on apply changes again, and let us try pinging again. Now you see the ping is not working. That means now this machine cannot connect to any of the other devices that is present on my home network. So we have successfully contained this machine to connect to just I think the internet will still be working, right? So it will just route to internet and no other devices. Now one issue that would create is our Ubuntu sits at the WAN, right? Because this is a logging server. So if we log in, we check the IP. I think it will not be installed. Yes, we will have to install. Just copy and paste. Okay, the IP is 192.168.0.136. So if we try to ping even that from here, it will not work. Now this creates an issue because we want to send the telemetry and the logs and the processes or the data that's happening on this Windows box to that logging server so that we can monitor this machine from there. So what we'll do is we'll create a new rule. Click on add. We'll say this time this will be pass on LAN. Protocol should be any, source is any, destination is our logging server, and the subnet mask should be of 32 because we just want that IP to be reachable and nothing else. We will mention description allowing traffic to logging server. Click on save. We'll move this rule to the top and we'll apply changes. Now this should actually limit the connection to just that logging server. We'll try that out. We'll try to ping 192.168.0.239, which is our host operating system, right? 239. Yes. And it should fail. But if we try logging to 165, which is our Ubuntu logging server, let us check the confirm the IP. Okay, sorry, it's 136. 136. It is working, right? So we have successfully contained the Windows box traffic to just flow to either internet or the logging server and not allow it to connect to any other device on my home network. So we'll be wrapping up this video here. So we have today created two virtual machines, one Windows, one Linux, and we have set up firewall networking and configuration to contain and have absolute control over those Windows boxes. Stay tuned for more such videos. In the next video, we'll be covering up how to install other security solutions and tools for setting up this lab and moving it to the next phase. If you like the video, do like and subscribe for more related content and videos.